first lesson in Unit 4 is looking at factoring polynomials, okay? The thing is, the first step in factoring is always GCF, right? So if you get a trinomial like this, you need to scan it and see, is there a GCF? Yeah,
it is. It's
there
3y.
That's what I'm saying.
3, 9, and 54. Your GCF is 3. And y, good, because they all have a y. You can't take out x because not all of them have an x, right? So 3y, and then we open up our parentheses. That means everybody gets divided by 3y, okay? So then, that tells me I have x squared plus 3x minus, isn't it 2? Oh no, sorry, 18, sorry. Brain. Okay, 18.
I got it.
My brain. Okay, so, okay. Alright, so all I did was GCF. I divided everything by my GCF, yeah? And some of you guys know what the GCF is, and you can divide it all out, but then you forget to put your GCF in the front of the parentheses. You must do so, okay? Yeah.
Why does it need 1212 on here?
Oh, I don't know. I'm just the numbering. Sorry.
Done.
Okay. So now, the thing with factoring is that you need to make sure that you factored everything, okay? Once you take out your GCF waits. So basically, things that are inside the parentheses, am I done, or can I factor it further? 1, 2, 3, I have a trinomial, so I'm going to say, okay, this is AM, right? Let's see if it works. Two numbers that multiply to give me negative 18 and adds to give me 3. Negative 3 and 6. Good. Yeah. And remember, your calculator trick, if you need to, okay? On the calculator, you can go into y equals and put negative 18 divided by x. Go to your table, and it'll list out all of the factors for you. Okay? You just have to see which one adds to give you 3. But thank you, Jose. So since we have negative 3 and a positive 6, we have just a plain old x squared. That means I can go straight into my double parentheses, x and x, right? Minus 3 because there's a negative 3, and a plus 6 because it's a positive 6. Please don't forget to bring down your GCF. And then you're done. You can't factor this anymore. Yes? Questions? All right. Okay, let's try the next one. Mary said the numbers are weird. They are. They are.
Thanks.
Apologies. All right. So let's look at this one. GCF?
Yes, B.
Good. Okay, so different color. B, B, and B. 2, 5, and 12. There's no GCF. It's 1, right? So the only thing that we can take out is B. Sure. Let's do that. So B goes out in front. We divide every single term by B. And then we get 2a squared minus 5a minus 12, yes? All right. Just jumped right into the deep end, right? You remember this? This is AM, right? But this is the fun AM. I have a 2 in front. Yeah? This means I need to take this guy, swing it over, and multiply it with my C number, right? A times C. Okay. So then that gives me my new M. What is 2 times negative 12? Negative 24. My A number still stays the same, which is negative 5. All right. What two numbers multiply to give me negative 12 but adds to give me negative 5?
3, negative 8.
I'm just going to circle B. I'm going to write wait. All right. So I don't want to bring it down. It's going to get messy. Just let B wait. What I'm going to do is, whenever we do this swing way, you have to bring down the first, bring down the last, and rewrite the guy in the middle. So bring down the first, 2a squared. Leave some room. Bring down the last, minus 12. And this is in your original one, right? You're not saying minus 24. You're saying minus 12. Okay? Now, in the middle, I have negative 5a. I'm rewriting that guy using the two numbers that Austin told us. So I have a positive 3a minus 8a. Those variables need to be there. Okay? Questions? Coming back? Now we have 1, 2, 3, 4. Wait, how do you factor when you have 4 terms? Good. Split it right down the middle, and you're going to GCF both sides. Okay? 2a squared plus 3a, and that's just a, yeah? Was 2a plus 3. On the right-hand side, oh, what's it starting with? Negative. Make sure you bring that negative out. 8 and 12, what is their GCF? 4. The negative 4 comes out. So 2a plus 3. How do I know if I did this right? Good. The parentheses should match. They should be the same. And if it does not, you need to go back and check, because it's either not factorable or you did something wrong somewhere. Double parentheses, 2a plus 3. What goes in the other one? A minus 4. Don't forget to bring down that GCF that was waiting for you, right? And then there you go. That's it. Yes? Okay. All right, should we try the next one? Okay. All right, so let's look at this. Do we have a GCF? No GCF. Wait, but I have more than one variable. I have an X and I have a Y, right?
Can't divide anything out.
Can't divide anything out. But this is that fun stuff I was telling you about. You guys can factor this. Whenever you get something where you have more than one variable, it looks a little funny like this. Well, it still follows the same rules. This is still a trinomial, so I could do AM, right?
So, a negative 6 and 1.
Okay. So let's see. Let's go get our numbers. Two numbers that multiply to give me positive 6, but adds to give me negative 5. Multiplies to give me a positive 6, but adds to give me negative 5. Not negative 6 and 1, because that multiplies to give you negative 6.
Oh, yeah. Negative 6.
Good. But it doesn't. Okay, so negative 2, negative 3, negative 5. Okay? All right. So, this is a weird one, right? Anytime you have the weird one, you got to do the bring down the first, bring down the last. Bring down the first, x squared. Bring down the last, 6y squared. Right? Okay? And then in the middle, you have negative 5xy. You have xy as your variable. That's your term in the middle, right? So we're going to plug in these numbers so we can rewrite this, but we got to write them with xy. And then minus 3xy. That way, we're rewriting negative 5xy. Okay? And then 1, 2, 3, 4 terms. What do I do? Yep. You guys are gonna get sick of me saying that for this lesson. And then let's find the GCF. GCF of the left-hand side, X. GCF of the right-hand side, thank you, negative, because it's starting with a negative, 3y. Thank you, Hannah. And be careful, that's x minus 2y, because you had a 6y squared divided by a negative 3y, right? You have two y's on the top and one on the bottom. Did I do this right? Yes, and we know that because the parentheses match. So now we can go into our double parentheses to x minus 2y. Uh-huh.
I put the negative 3 before the negative 2.
That's okay. Then inside your parentheses, you should have x minus 3y.
Yeah.
But they match, right?
Uh-huh.
Then you're good. You're good. X minus 3y. Because if you guys switch your numbers in the middle, that's okay. Just make sure that your parentheses match and your final answer should look like ours. Okay? It just flip-flops what was actually inside the parentheses. Okay? And then we're done. There was no GCF that was waiting, that needs to come down. We're good. I can't factor those anymore. Any questions? Okay, let's try the next one. All right, so this guy is the same thing, right? Except we have A and B. All right, there's no GCF. AM. Two numbers that multiply to give me negative 40, adds to give me a positive 6. You guys try this, please. All right, so for this one, you should have what? Good. Perfect. Bring down the first, because this is a weird setup, right? Bring down the last. And rewrite your 6AB using the two numbers that Isaiah gave us, right? Plus 10AB minus 4AB. Yes? All right, we have 4 terms, so we need to divide it right down the middle. Find the GCF of both sides. Left side is A. On the right side is negative 4B. A plus 10B is what I have inside both of my parentheses. Yes? So this is A plus 10B times A minus 4B. No GCF to bring down, and I can't factor anymore. We okay with this? Good? It's not bad, right? It's not bad. All right. Okay, so let's look at this one. Wow. K to the 4th. K to the 4th. K squared, and then the number. Well, I realize we only have one variable that we're working with, K, right? But it's still a little weird because it's K to the 4th, right? So it's fine. It's still AM. You're just going to do the bring down the first, bring down the last, okay? Two numbers that multiply to give me 24 and adds to give me 11. What are they?
8 and 3.
Good, thank you. 8 and 3. So since this is a K to the 4th, it's different from what we're used to. Bring down the first, bring down the last, and let's rewrite this 11K squared using the two numbers that Cooper gave us. So plus 8K squared plus 3K squared. right? Now we're going to divide this right down the middle. Oh, what's the GCF on the left-hand side? K squared. Good. You have k to the fourth and k squared. K squared is the smaller one, or smaller exponent. How about on the right-hand side? What's my GCF? 3. Did I do this right? Yes, because my parentheses match. And then I'm going to write it in my double parentheses. So here's where we see a lot of mistakes, right? These two are done. I can't factor it anymore. But just be mindful that when you end up with k squared or x squared,
For -4.
yeah, see if you can do another dose or if you could do another so. You know what I mean? Because that's when that stuff happens. When you have k squares or x squares left over, you got to see if you can factor these again. Because that's when you have things like, what if you had k squared minus 4? That's another dose. Then you got to keep going. So just be mindful of that. This one is good, okay? But I'm just saying, just be mindful. All right? So let's look at the next one. All right, I want you guys to try this. It's just like the one we did, except it's G's now. All right, with the 2 minutes that we have left before lunch, let's do this one together. Two numbers that multiply to -10 and adds to -3. What are they? Thank you. -5 and 2.
These numbers are the same quantity there.
So, since it's g to the fourth and g squared, I'm going to bring down the first, bring down the last, and I'm going to rewrite this -3g squared using the two numbers that Dylan gave us. Minus 5g squared plus 2g squared. And then divide it in half. G squared g squared minus 5. Yeah? Okay. On the right hand side, there's 2. G squared minus 5. So good. G squared minus 5 and g squared plus 2. Guys, can I factor any of those further? Is it dose? Is it so? That's it. And perfect. Right? Time for lunch. See you guys. When we come back, we'll finish. All right, let's look at the next one. So, first step in factoring, GCF. Does this one have a GCF? Yes. 4b squared. Okay. Divide everybody by 4b squared. So if you have b to the 6th on top divided by b squared, how many b's do you have left over? 4. You subtract. Or, guys, this is what it is, essentially, right? If we were to break this down. You have 6 b's on top, 2 on the bottom. Those, look, you have 4. Right? Minus 5b squared plus what? 6.
6, sorry.
Right? Okay. All right, so now my GCF is just going to wait. And then we want to look at the trinomial that's inside the parentheses, right? AN. So two numbers that multiply give me a positive 6, but adds to give me a -5. What are they? -3 and -2. Good. Thank you. Hannah?
We did that over on another one, right?
Yes. All right, so we're ignoring the GCF for right now. We're going to bring down the first, bring down the last. Okay? So we need to rewrite negative 5b squared using the two numbers that Hannah gave us, negative 3 and negative 2. So negative 3b squared, negative 2b squared. Right? Sorry, that is a 6.
Not
Not
looks
good.
like it's an eyeball.
You know what? How about this? Capital B's. There. All right. So we're going to divide it in half. B squared. You don't have to make them capital B's. I'm going to, just because my 6's and my B's are starting to look very similar. B squared minus 3. On the right-hand side, my GCF should be negative 2. Guys, it's starting with a negative. Yes?
Will it be to the second?
So b squared minus 3, I know I did this right because my parentheses match. And then I also have b squared minus 2. Didn't I have a GCF way in the beginning?
4b3.
4b cubed squared.
Oh, 2. Sorry.
No, that's fine. There we go. And there we go. B squared minus 3 and b squared minus 2, those are not those because 3 and 2 are not perfect squares, right? So there you go. Any questions? All right, let's try another one. Okay, you guys try this one, please. Here's the first part of this. Putting my work up here just to make sure that we are all doing the same thing. Okay. All right, do we have this for this one? Okay. Guys, if you get any exponents that are greater than x squared, okay, as your leading term, then you know what? Just use the grouping way. Bring down the first, bring down the last, okay? And that way they're, you know, you are not, what is the word? What am I trying to say? Then you, yeah, yes, right? The chances of you making an error would be less, right? Than kind of skipping forward. Yeah. All right. Let's try the next one. My goodness, there's so many of these. Okay, let's go on to this one. No GCF. 3 terms, so AM. M is 12, A is negative 7. What are my two numbers? Thank you. So since it's m to the 4th, I'm going to bring down the first, bring down the last, rewrite this minus 7m squared guy into these two numbers that Will gave us. Minus 3m squared minus 4m squared. Divide it in half, find the GCF. On the right-hand side, your GCF should be negative 4, right? Please be careful if it starts with a negative. You need to bring that negative. All right, so for some of you guys that worked ahead, you're no longer at this problem. Go back to this and make sure you finish this, because look at that. What else can I do? Good, good. You can dose this one. You have m squared minus 4. It's a difference, and they're both perfect squares, and it's 2 terms. Yeah. So what does this become?
4 is a perfect square, that's why you do it. Because 3 is
3 is not.
Okay.
So remember, dose, double parentheses, opposite signs. What's the square root of m squared?
2.
M. What's the square root of 4? 2. And then you can't dose m squared minus 3, so just bring that guy down.
So once you go for like possible.
Yes, absolutely. Remember, the point of factoring is to get it down to the most simple, basic factors, okay? You gotta keep going if you can. So if you skipped ahead, please make sure that you dose this out. All right, let's try the next one then. All right, you guys try.
Miss Hospital. I don't understand for the second one with the 9. How would I do that one?
Okay, which one was that? Am I almost there?
No.
No?
It's on the grouping.
9a squared.
Yeah, but like what are
Are we here with this one? Okay, listen, I wanted to put my, am I done here?
No.
No.
Why? How?
What can I do here? Thank you.
That does, wait, why?
Because you have x squared, which is a perfect square, 1 is, which is a perfect square, and you have a subtract. 2 terms, difference, and they're all perfect squares. Okay? So if you dose this, then you get x plus 1, x minus 1, yes? And then bring down x squared plus 7. Now you're done. So if you skipped ahead, please make sure you dose.
What was that?
It was the
It's
last
the
one.
x to the 4th plus 6x squared minus 7. Oh, the last one on the first page?
Mhm.
Okay. Finally, we're moving away from the first page. Okay. Ready for the next one? Okay, so the next section is grouping, which you guys should be pros at now because look, how many terms?
4.
4. What do you do when you have 4 terms?
Split it in half.
Separated.
Good. But is there a GCF in the whole thing?
No.
No. Okay. Because don't forget to check for that. All right. Let's find the GCF of each half. 3m squared. Huh?
Nothing.
I think there was a way on there.
All right. And then the right side, we have n cubed. So I know I did this right because my parentheses match.
That's the most basic, like,
This, yeah, because you can't do any more. And there's no GCF.
None of them have GCFs.
Sometimes they do.
No, they don't.
Okay, well, no, maybe our problems don't, but sometimes the grouping, the 4 terms, sometimes they do have GCF, so just be careful, okay?
4, 2, 6, 8. Boom, GCF right
But to be honest with you, if you forget to GCF from the whole thing, when you guys go to factor, you'll see your factors have a GCF. So then you just GCF it again later. That's fine, you know? All right, try the next one. Ooh. GCF for the whole thing?
No.
No. Okay. 1, 2, 3, 4. Divide it right down the middle.
X squared, y cubed. Yeah.
All right. X squared y cubed. Just take your time with it. Oops.
Cube
Obviously.
y
I
squared.
know, right? Obviously you can't write and think at the same time. Okay, there we go. X squared y cubed 3x minus
2.
2. Alright?
And then you divide by -3.
Good. On the right hand side, negative 9x plus 6, your GCF is negative 3.
Huh?
You get cross-eyed.
Um,
X squared y cubed minus 3.
well,
Can I do anything else?
no.
No. That's it. There we go. Done. So much practice. Questions? Looks like some of you guys are just waiting for me. Is that what's happening?
No.
Some of you guys ahead?
No.
I don't know what to do for
What are
the
you,
thing
some
with
for?
square.
All right. Let's go on to the next one. Try this one. Oh, I think this one's going to be interesting. There's no GCF for the whole thing, so I'm going to divide it in half. X squared on the left-hand side. Negative 9, that's my GCF on the right-hand side. Am I done? No. Thank you, Elise. What should I do? Thank you. X squared minus 9 is a difference of squares. So is x plus and x minus what?
3.
Don't forget to bring down your x minus 2. And guys, if you ever factor through and you go, wait a minute, did I do a dose when I needed to? Or did I just do it because I made it up? Well, you know what? You can FOIL this.
A mega four.
Yeah, well, so
Just
just make sure you do 2 at a time and then multiply that with the other one. Okay? So it'll be like double distribute and then triple, so then you should get that.
Wait, I have a question.
Yeah?
Does that mean when you do that for the first x minus 2, you would take that x, FOIL it to the first one, and then FOIL it to the next one?
No. Do this first and get your trinomial and then multiply that with your x minus 3. Do you want to see it?
Nah.
Huh?
Yeah.
Yeah? You know what? How about if we factor through and then we'll come back to this? Okay? When we're done factoring, then I'll show you. Because you're right, it will be helpful to know. All right? Okay. All right, let's try this one. 1, 2, 3, 4. No GCF for the whole thing. Divide it right down the middle. 9a squared. Okay. A plus 2. Negative 1. Okay. So then we have a plus 2 and 9a squared minus 1. Yes?
What about the GCF that was
Am I done here?
No.
There's a difference of squares. Guys, this is a dose. If you look, you have 2 terms, and you have a subtract in the middle. 1 is a perfect square. A squared is a perfect square. And 9 is also a perfect square.
Magic.
So now double parentheses, opposite signs. What is the square root of 9a squared? 3a. And you know what, since that is in this first term spot, you have to put it in the first one together.
1.
And then square root 1 is 1. There we go.
that's another one.
Good. Perfect. And then that's it. And then you're done.
Now please show us how to do different squares.
Oh yeah, are we there now?
Yes.
Okay. All right. So are we okay with this? Am I moving too fast?
Not at the moment.
A little bit? Okay.
I'm excited to see if I got it right.
Hold down just a little bit. Are we okay with this one? Do you need me to go back to any of the other ones? Okay. So now let's talk about difference of squares when our exponent is bigger than 2. Okay? So 16. Okay, all right. So here we go. There's a minus. We have 2 terms.
Why did you make it bigger?
Well, I just wanted to emphasize that. I didn't realize I was holding blue. Is 16 a perfect square?
Yes.
Yes. Is 1 a perfect square?
Yes.
Yes. But, you know, x to the 4th is also a perfect square because square root of x to the 4th is x squared. You know how you can also do that? Just divide this exponent by 2. Divide it by 2, and then you get x squared. Yeah? If you have an even number exponent, you can take the square root of it. Okay? So if it's x to the 4th, you can square root x to the 4th. X to the 8th, you can square root it. It's an even number. What's 8 divided by 2?
Oh, so you divide by 2.
Yeah, just divide by 2, and it gives you the square root. Yeah.
I have a question. So for this one, when you do that, since it ends up coming out 4x to the second.
Okay, wait, so let's do
1.
that.
Well, no, but I have.
So everyone can hear. Okay. I will listen to your question. Those double parentheses, opposite sign. Okay, Mary, what were you saying? What's the square root of 16?
It's 4x to the second, but I have a question for that.
Yeah.
Because of that, wouldn't you make it and branch off even smaller from that so you have 4 of them?
Absolutely.
Okay, I wanted to make sure that I wasn't just seeing things.
But not 4.
Wait, yeah.
So 4x squared plus 1, 4x squared minus 1. Do you agree?
Yeah, but they would both be able to split off.
No.
Why not?
Those is difference of squares. That is
Square
addition.
root of
You don't-
16
you're
is
not gonna do
4.
that.
Square root of 1 is 1, right? Does everyone see this? Does everyone see where I got 4x squared plus 1 and 4x squared minus 1?
Those rules
All
are
right.
stupid.
So now, can I do anything further here? Yes. Yeah, you can dose this one, not the first one. Why?
Because it's plus.
Because it's plus, it's not a difference. So this one can just come down, 4x squared plus 1. However, the other one, 4x squared minus 1, that's another dose. What's the square root of 2x squared, 4x squared?
Huh?
2x. Okay.
1.
Square root of 4x squared is 2x.
1.
And what is the square root of 1?
1.
1. Okay?
So that's
Yeah, that's it, because you can't factor any of those further. All right, Jaden, you okay with that? Okay. All right. Let's try another one.
Divide by 2.
Okay, so
Why not?
81. No. Oh, you mean
Yes,
the
it
okay.
is. No, not the exponent.
So-
81 divided by 2 is 9, isn't it?
Yeah.
What?
So, do they have a GCF here? No GCF,
Oh,
right?
dang it.
So I have 2 terms, a subtract. Is 81 a perfect square?
Yes.
Yeah.
Yes. What's the square root?
9.
What's the square root of 16?
4.
And what's the square root of k to the 8th power?
4.
Good. Since it's an even number, you can square root it. Oh no, God, I just keep. Okay. Divide it by 2, and then you get k to the 4th.
Make it tinier.
Right? All right. So then this is a dose, double parentheses, opposite signs. And you know what? I know that we like having our variable on the left side, but for this one, they didn't. They put it on the second one, the second spot, right?
Can we
So
switch
just
that?
keep it in order.
What?
9 goes first. And then the second one is 4k to the 4th. Right? And that's okay. They can mix it up. All right? So now, am I done here?
No.
No. Not. This guy, you can dose further. Is 9 a perfect square?
Yes.
Yeah. What's the square root of 9?
3,
What's the square root of 4?
2.
And what's the square root of k to the 4th?
Squared.
K squared. Yeah, and this is subtract. So double parentheses, opposite signs, 3 plus 2k squared and 3 minus 2k squared. And then I'm going to bring down 9 plus 4k to the 4th. Does everyone see that?
Yes. And you can divide the next one by 9.
And then this one is done because you can't factor those any further. All right? Okay. Talk to me. How's this? We okay?
Splendid.
All right. Let's try the next one. Oh, 225 and 81. You know, so I have x's and I have y's. With this, I would just, run through in my head. Okay, 2 terms, there's a minus. Both of my exponents are even. That means that I can square root both of them, right? Even though it's an x to the 6th and y to the 10th, that's fine, right? Square root of x to the 6th turns into x cubed. Square root of y to the 10th turns into y to the 5th. Don't you agree? All right, yes.
You probably won't give us like a odd, like odd exponent, would you?
No, and you can't do a difference of squares if it's an odd exponent. All right, so here's the other thing I'm going to ask myself, okay? I know 225 and 81 are perfect squares. However, those numbers are pretty big. Do they have a GCF other than 1?
9.
Is it 9?
Yeah, I got 25.
Do you guys know how to check?
Mm-hmm.
So you can go to your calculator, go to math.
You could just divide 225 divided by 9.
Well, and that works most of the time. I just want to make sure that that is the biggest one.
Okay.
If I go to math number into this thing called GCD, put in 225, comma, 81. Okay, remember, it doesn't let you put in negatives, and you can only put in 2 at a time. If you get like really big odd numbers, you just want to make sure that you're getting the biggest, the greatest common factor. You can do this. It is 9. Okay? So that means you need to take the 9 out first before you even do the dose.
It's 25x 6.
225 x to the 6th divided by 9. Yeah.
25.
Positive. You can't put negatives into the calculator when you do the GCD. Okay? And look, there are still perfect squares, right? Except we took the GCF out, which we should. All right? And then now we're going to let this 9 wait, and we're going to dose inside the parentheses. So double parentheses, opposite signs. What goes in this first spot?
5x 3.
5x cubed, right? Because square root of 25x to the 6th equals 5x cubed. How about in the second spot? What goes in there?
3y, 5.
Good. 3y to the 5th. Okay. And And then don't forget to bring down the 9, and then you are done because you can't do anything more with that. All right, it's very pretty. Can't do anything more. All right, questions? Okay, so try this, please. All right, so a lot of you guys asked me, wait, how do I find this GCD again? Okay, 32 and 98, those are pretty big numbers. I do want to find the GCD or the GCF. X to the 8th and y to the 6th, those are both even numbers, so they are perfect squares, right? All right, so math, number, GCD. What were my two numbers again?
32 and 98.
32, comma, which is above the 7, 98. Remember, you can't put negatives in here, and you can only put two numbers at a time. So then that gives me 2. All right. So that means a 2 can come out of everything. 16 x to the 8 minus, was that 49? Yeah. All right. Can I do a difference of squares again? Yes. So, plus, minus. I'm not going to do much, so I mean, I could circle this, but it's just right there. What is the square root of 16x to the 8th?
4x4.
4x to the 4th. Remember, divide it by 2. Divide that by 2. Okay?
7y3.
4x to the 4th. And then square root of 49y to the 6th
7y3
is 7y cubed. And don't forget to bring down the 2. You can't break any of those down even further. This one, because you have a 7 and you have a y cubed, right? So this is done. Okay? Question? All right. So the last part, the soap way. Okay. All right. So if we look at this, you know what? You should always check and see if they have a greatest common factor, right? Especially with these bigger numbers. 125 and 729, do they have a GCF?
1.
It's 1. Okay. Meaning, no. All right, we don't want the 1. So if I look at this, I have two terms. I have x to the 3rd, y to the 3rd. Okay. That tells me, oh, maybe a soap, right? Is 125 a perfect cube? Do you know where to, 5? Uh-huh. 5. Good. Do you guys know where to go to find the cube root?
Uh-huh.
Okay, it's math, right?
Math 4.
All right. So 5. And you know what? You may get numbers that are bigger than 3. Here's the thing. You can cube root it if they're multiples of 3. Like if you could divide it by 3 evenly, right? So I know this is a perfect cube because then that'll be x. Is 729 a perfect cube?
9.
So it's basically like the same concept as difference of squares, but you're just dealing.
Make it tiny, tiny, tiny.
So remember, soap or the cubes, they have a different setup. So we have the 2 and we have the 3. Remember this one? So find the cube root of both of your terms. So 5x and 9y. Don't worry about the signs right now. We'll get to the signs after, okay? In this first one, you got to take your first one and square it. That means you're multiplying it by itself. What is 5x times 5x? No.
Oh, sorry.
25x.
25x.
Something.
And then in the middle, you have to take these two that you found and multiply them together.
But isn't that not possible because of the
No, you can multiply them. What's 5 times 9?
45?
XY. Right? And And then that last one, well, you got to go back to these two, right? We square the first one, we multiply them together. The only other option now is square the last one, right? 9y times 9y.
Wait, there has to be 81. Oh.
You see that? Good. And this is so same, opposite, always positive. So the same sign as your problem, which is plus, same. Opposite, which would be minus. And then always plus over here. Okay? It's a lot. I know. It's a lot. Just so you know, you cannot AM factor this trinomial that comes from a sum or difference of cubes, okay? That's done. The only thing that you may be able to do is maybe you'll get another dose out of this first one, or maybe another soap out of the first one. But that would be kind of mean. Just a whole lot of stuff to keep track of. All right, let's try the next one. 27 and 1,000. GCF? What, right? I see t cubed and r cubed, so maybe this is so. Is 27 a perfect cube? Yes, what is it?
3.
T cubed is a perfect cube. What is it? T. What about 1,000 r cubed? 10r. Well, there you go. Now you have your little binomial in the front. 1, 2, 3. Right? So there you go. 3t and 10r. All right. What goes in that first one?
9t to second.
Good. Is 3t times 3t. The first one squared. 9t squared. What goes in the middle?
30 TR.
Good. 30. You know what? I'm going to put RT because, you know.
But it's going to go next to a plus sign.
Oh, that's why I put the little tail on the T. All right. What goes in this last one?
100R squared.
Squared, right?
Yeah.
Good. 100R squared. Yes, I'm sorry. I heard you. I heard you. Okay. So 10R times 10R, right? Okay. Wow, you guys are doing a really good job. Now for the signs. Oh, no, I have it written up here. Same, opposite, always plus. All right, you guys try the next one. Actually, let's look
Try
at
the next one.
Yeah, no, this one's confusing.
Isn't it okay?
You need to look at it to understand, because you could take,
Okay.
it out.
Oh no, the next one's fun. We finally have a GCF, right, Ava? Do you see a GCF here?
Yeah.
XY cubed.
They both have an X.
And
This
a
one has
y.
X, that one has X to the fourth. So an X can come out.
And y to the third can come out.
Good. XY cubed. And that's it. That's what can come out. Okay. Divide everything by XY cubed. XY cubed. Oops. Sorry. Have to write something else. Okay. Well then, XY cubed divided by XY cubed gives me what?
Nothing.
1. It's something. Don't cancel it out and not put anything, okay? There is something there. It's 1. Alright? Plus, well, 27. X to the 4th divided by X is cubed. What happens to that Y cubed divided by Y cubed?
It disappears.
Alright, that goes away. That becomes 1. Okay. So there we go. We simplified it so that now inside the parentheses, oh, then that's just a regular old soap, right? Please pay attention to the order here. 1, 2, 1, 2, 3. I'm going to bring down the XY cube because that's just the GCF. It's not going to affect anything, right? If I bring it down early. What is the cube root of 1?
1.
1. What is the cube root of 27x cubed?
3.
3x. Yep. So there you go. These are your two terms that go inside that binomial parentheses, right? So keep it in order, okay? First one squared. 1, yeah. 1 times 1, right? Middle. 3 what? 3x. You have to multiply these two together. And what goes last? Huh? 9x squared. Yes? All right, now for the signs. So, same, opposite, always plus. Okay? Questions? Comments? Nice comments. Not any complaining comments. Good. You guys are doing a really great job. Do you want to try this one on your own?
Yes.
All right, do it.
Wait, I have a question.
So for this one, this is what I got. Did I do this right? Starting to get a little cross-eyed up here, being at the smart board for this long.
Oh, that's what I forgot.
If there's any, so I know that I have to do this way because I'm looking at these guys, okay? So, oh, and this, say that one too, right? It's not a subtract, so I know I can't do dose, right? Because you can only do dose when it's subtracting. But look at the 8. Try square root of 8. Do you get a nice pretty number? No, not for square root of 8, right? Square root of 8 doesn't give me a nice pretty number.
2.82? That's a good number.
Because g cubed is not an even number. Only even numbers you can do the dose because you can take square root of even number exponents. Okay? If you have exponents that are multiples of 3, so 3, 6, 9, 12, 15, like that, you can take the cube root of it. You can divide it by 3, right? So then if you see that, it's probably going to be so. Depends on the other numbers if they're perfect cubes. All right? But the biggest giveaway is the minus. All right? Oh, so look at this. This should be easier for you guys now. What's the GCF? 4. Thank you. All right, so then with this one, so Jaden asked, how do you know that you use the soap instead of the dose? Well, you know what? This one has a minus, and it has 2 terms. So I don't know, maybe it is dose. 1 is a perfect square, but it's also a perfect cube. But 8 is not a perfect square. 8 is a perfect cube. And f cubed is a perfect cube. So that's why you know that this is not dose. It's got to be soap.
So it's everything is like a perfect cube, and you have even bracket.
Yes. Yes. Then that's soap. Mm-hmm.
Then it's
Good.
cube.
Yeah. The sum or difference of cubes. Okay. So then with this one, cube root of 1 is 1. Cube root of 8f cubed is 2f. Good. What goes in the first one? What goes in the second one? What goes in the last one? Good job. Now, same, opposite, always plus. And there you go. Okay? And you don't have to draw these lines underneath. I just do it so that you guys know you know, just to kind of help you. Okay, but you don't have to. All right, so let's try this.
I can't stay after today.